5.3, looking at finding value. So page 263, let's take a look at try it yourself number 3. The monthly utility bills in a city are normally distributed with a mean of $70. So that's going to give us our mu equals 70 and a standard deviation of $8. So that's going to give us a sigma of 8. Find the x values that correspond to z-scores of negative 0.75, 4.29, and negative 1.82. So we're going to use our formula to find the x, which is just mu plus z sigma. And this is just taking our z formula and use a little algebra and changing it around. If you want to put the z sigma before the mu, you can. So the first one to look at is negative 0.75. And we're also going to make a conclusion here, just like whether it's less than or greater than. And this one's going to be really big, much bigger than. And so for z equals negative 0.75, we're just going to calculate x equals 70 plus the negative 0.75 times the 8. And so we're going to multiply those two together, and that'll give us 70 plus a negative 6, which will leave us with $64. So that's the utility bill that goes with that z-score. And so we can interpret that as being less than the mean and say that that's just less than the mean. So the next one we're going to look at is z is equal to 4.29. And using the same formula, we're going to have x is equal to 70. In this case, we're going to add 4.29 times the 8. And so we multiply that 4.29 times the 8, that's going to give us $34.32. 34.32. So we just add those together and we get an x of $104.32, which is definitely above the mean. I would say that it's much higher than the mean. Now let's take a look at z is equal to negative 1.82. So then our x is going to be equal to 70 plus negative 1.82 times the 8. Multiply those together and we'll end up with 70 plus a negative 1456. I'm going to subtract those and we're going to end up with a utility bill of $55.44, which I would just say again is less than the mean. C4, section 5.3, try it yourself number 4. The braking distance of a sample of Honda Accords were normally distributed. On a dry surface, the mean braking distance was 142 feet and the standard deviation was 6.51 feet. What is the longest braking distance on a dry surface one of these Honda Accords could have and still be in the top 1%? Now you have to remember that the shorter the braking distance, the better. So we're actually looking for a small number to be good. So if we draw our curve here, then the top 1% is actually going to be this little bitty 1% down here because we want to get a negative z so we can get a smaller number. And this is going to be 0.01. When we look up the alternative method, we're actually going to look for this percent here between 0 and z to find our z, which is 0.49. And so what they've given us here is that the mu is equal to 142 and the standard deviation is equal to 6.51. And so we're not forgetting that the shorter the braking distance, the better, so we're actually going to have a negative z here. And so what we're going to do is we're going to look inside for 0.4900. Look inside of our table for 0.4900. So when we go to our table, when we look inside for the closest thing to 0.4900, we find a couple numbers around it. We find 0.4898 and 0.4901. We find 0.4898 and 0.4901. Well, this is 2 away, and this is only 1 away. So we're going to go with this one. And so to find out what the z is here, 0.4901, the 1s and 10s is 2.3, and so we go up and we find 0.03. So that's going to be 2.33, but it's going to be negative. So we're going to use a z equal to negative 2.33. And then we're just going to use that formula where x is equal to mu plus z times the standard deviation times sigma. So our x is going to be equal to here 142 plus our z, now it's negative because we want to have a low braking distance, times the standard deviation, which is 6.51. So we're going to multiply that negative 2.33 times the 6.51, and that gives us a negative 15.1638. I'm good with 2 decimal places, and you just got to pay attention to what the computer wants. And so when you combine those, you end up with about, let's go with about 126.83. And so to interpret that, we'd say that about 127 feet is in the top 1%. It'll probably be multiple choice or something like that to the rounding. In 5.3, page 265, try it yourself 5. The length of time employees have worked at a corporation is normally distributed with a mean of 11.2 years and a standard deviation of 2.1 years. In a company cutback, the lowest 10% in seniority are laid off. What is the maximum length of time an employee could have worked and still be laid off? So we're going to be looking for this 10% down here at the end. Because the 11.2 is the mean right here in the middle, we're going to find the highest number that reaches this 10%. So 10% in form of decimals is going to be 0.10, but our table, we're using the alternative method, is going to tell us this right here, from 0 to z, which is 0.4, 0.4000. So our z here is going to be negative z that we're going to put in our formula to find out the value, the number of years. X equals mu plus z sigma. And they've given us the mean and the standard deviation, so we need to find this z. And so we're going to look inside of our table for 0.4000. So when we look inside of our table for 0.4000, then the closest thing we find is this 0.3997 and 0.4015. 0.3997 is going to be closer, so the z-score that corresponds with that is 1.28, but we know that needs to be negative. So our z is going to be a negative 1.28. And so we're going to plug our values in here. The mean they gave us was 11.2. The z that we found was a negative 1.28. We're going to multiply that by the standard deviation of 2.1. So we're going to multiply those together, and when we get that product, add to the 11.2. So that product is going to be negative 2.688. Combine those, and that'll leave us with 8.512 years. So let's interpret that. And so our 8.5, that's about 8.5. So an employee could have worked for about 8.5 years and still be laid off.